Hello everyone, it's Peter here, Piotr Fissner. How you doing, guys? So, in today's episode we've got an Acer Nitro, and this laptop has a short on the 19 volts power rail. Now, I've identified area where the short is, and I would like to show you the IC, which I don't know yet if that's the IC. I just want to show you why we need the right to repair. Okay, let us switch to the microscope. You see bevel. So this I see here, yes. I'll put the probe into the ground. I'll get my meter into the diode mode. Ohms, let's do diode, so it will be beep when I will touch the ground. Beep. But as well, look at the bottom of the bevel. Yes. So if that would be a, let's say, ground, which is, I would say, not, then this one would be a ground or not. Yes, so capacitor shouldn't have short on both sides. So then again on this side, and if we will turn the board as well, where do we have? Yeah, more closer on this side here. Oh, that's why you're disturbing us. Okay, it's here where those two colored ones are. Ground again, and let's see where we are. Okay, so on the right side of these capacitors and on the left side of these capacitors. Now this is a regular NPN transistor from top of my head. I didn't check the specification, I just see it every so often. But on the other side, okay, let us put some light on because it's quite dark. It's quiet, yes, so I wouldn't say it's a 7506, yes. Now this one again, like here and here, of course, is the bottom of the 7506. So I wouldn't say, there's any issues with these two. Yes, okay, maybe one of those two caps, maybe. So either removing this or on the other side remove that one would tell us more. Because here I don't see any discoloration on this one. So I wouldn't say are those free. I wouldn't say it's this one. I would say it's not this side. It's more down on the other side. So again, how to be 100% sure? Well, remove it. Yes, remove it. So this one, and the second side is here. Look, nothing. Okay. So you see, so it has to be either these two caps or on the other side. This is PLB, this is no way, this has to pass the current on both sides, yes. But either here or I'd say here will be the issue. I was attaching current and I can't see anything getting hot enough to recognize. So yeah, I don't know, what do you bet? It's faulty, but I know both sides shouldn't beep, yes. So I'm thinking remove this PL because that will cancel the transfer to the other side of the board, I'd say, because these ones are responsible. And if no, yes, if it will be still, remove this cap, and then we know that the only connection from here to the other side of the board will be through those two vias, and see which one will have a short still. Yes, so that's my plan. I'll pause the recording, I'll do it, and then we can go back. Okay guys, so I'm confused. I removed those, as you can see. Here I've put aside the second one. In that case, if we know that it's not here, it should be on the other side where the bevel is. Bubble. Yeah, I've heat up a bit this thingy, but I still got a short, and I'm a bit confused because the short is now not on this side, so in this case this chip looks good to me, but the short is on this side, so yeah. So I can't blame this bubble chip at this moment. I'll put down again, now it's cooler. I mean the main board is just cooled off. Switch. On the standby my hot air is giving noises like EMF you would hear, yes, or EMC, whatever it's called. Anyways, let's go back to the ohms reading. Okay, I can put diode event mode, and now we can see that here will beep, but here, look, it doesn't beep anymore. So I wouldn't say this chip is faulty. That's a minus. Yes, you know, it's not electrolytic, you don't have plus and minus as such on the capacitor, but you've got always minus and positive side, yes. Yeah, electrolytics you can't use on the high frequency ones. Everything was high frequency, let's say you can use like ceramic and others, yes, but you can't use electrolytics. Electrolytics you can only use on low frequencies. So yeah, so then when you come to here, you see it's okay, and when you check here, it's a short. So this is the PL, it's not a L symbol, it's for inductors, and this is not the how do you call it, this is not a capacitor. Okay, so when you see PL, don't take it as a capacitor. It does have even different color. I can show you here for those who don't know. Okay, this is darker, and these are not capacitors, those darker ones, yes. But anyways, back to the topic. So we know that it's not this, so the question is what it is. Well, if I removed on the other side, and we had plus and minus side as well here, and I remove that, and if we know that that's not the case, so we know that this side, yes, this side, okay, my minus is not connected, my probe, negative probe is not connected. So here we've got a short, okay, and that's the minus side, which is okay to me, yes. But here again, if those capacitors weren't the culprits, something has to be culprit on the bigger side, okay. And for me now to find it without taking a lot of amps, it's quite challenging because it can't get hot too much, and I can't blame as well the CPU or GPU at this stage, because they've got a small but still resistance, and it's, I'll put aside those two to not lose them. Okay, they are out. And still, let's get those coils here, yes, and let's put probe back, and we still got, let's switch to ohms, we still got 2 ohms, 1.9, 1.8, yes, like this. So we still got resistance on them, okay. So I wouldn't say the CPU is faulty. I would say for now it's not the case, because 1.7 to 1.9 is okay, yes. So I can't say that's 4.6, and this will be more as well. Yeah, 14 point, that's okay to me. And on the graphics card, yes, it's a bit of a problem, because the graphics card ones are only 1.1, but it's still 1.1. It's still not 0.2 or something. So, you know, I wouldn't say that's the problem, okay? I would say that's looking like a double MOSFET to me. And this randomly touched is okay. Yeah, that's ground, so this is point, oh no, that's 0 on both sides, so I don't know which one is a ground. So blindly, are those, okay, so if that's a minus, so that would be a positive side, because that's looking like a minus. No, it's 0, 0, 0, 0.000, and 0.000 on this MOSFET, okay? On this MOSFET, 0.0 and 0.0. That's OL. And again, not bubble or bubble, but Bobby. So to be true, I would have to remove blindly some things in order to verify what's wrong. But at this moment, it's guessing. Yes, it's guessing. For me, yes, if I see MOSFETs with shorted capacitors like here, that's 0.00. If I would switch to the diode mode, you will hear the beep on this side and on this side. Yes, and that's the only place I could find. The rest of the places, yes, the rest of the places is just gamble, but you know, like the main thing is that our main power rail 19 volt is shorted. So if I know that, let me switch this off and let me switch to the camera. So the main 19 volts is shorted. It doesn't take so much current that you could use your thermal camera or spray IPA and see something bubbling, because it doesn't take a lot of current. CPU or GPU doesn't get hot when I'm putting like 1 volt or something, and I could force with some batteries, maybe several batteries AA in a parallel, and then force more current through, because my power supply doesn't push through, so maybe batteries would, you know, would create more current flow. But I don't know of any other way to approach this topic, because to be true, if you have a board where you can push through current and see the outcome, it's easier. But when you get a board where you're trying to push current and it doesn't go through, and you know you can't increase volts, because of course if you will increase volts then you will push more current, but again, push more current, then if the CPU or GPU are good, you'll burn them. Yes, again, this could be still a problem with CPU or GPU, but because it doesn't take so much current, I can't verify. So if anybody knows any other way to test it, please let me know, because I'm stuck with this board. I don't know what else I could do. If I can't push more current through, for me it's a no fix for now. I'll need to let customer know that because I can't push through more current, I can't do further tests, and in that case only replacement of the mainboard would be a vital solution for the customer, or blindly start to remove things and blindly start to do, which doesn't have any money value for the customer, and it's more of a wishing and hoping rather than anything else, because that's guessing. I don't like guessing. Yes, I'm trying to show you here only those worst case scenarios of repairs, and then maybe somebody smart can comment down below one day and say, oh, you could do this or that. Yes, and people could look, because I'll pin the comment, and maybe people can learn out of it. But for the moment, I'm trying to record those repairs which I do on a daily basis, and I stuck somewhere. Yeah, so sorry that I can't show more, because I don't know where to go with it. And that's it, guys. That's everything what I wanted to show. Yes, I wouldn't even show this video if I would remove those components and there would be dead capacitor, because you've got other YouTube channels showing it, so it's easy. Yes, and easy. It's not always in the repairs. Yes, many times in the repairs you will find such things and you will just be like, why? So I wanted to show you this, and maybe some smart person can comment down below and can tell us what to do next, because for me, no fix. That's it, guys. That's everything. Yeah, it's easy to find a dead capacitor and replace it and show, yeah, look at my video, I can fix stuff. Yes, many people can fix stuff still, but understanding the fault behind it and finding a solution, not everybody can. Yes, so hopefully somebody can help us, guys. Thank you for watching. See you in the next video. Bye bye.